lecture note that I have discussed with you, and I've also uploaded this in the e-learning. We have also looked at some sketches of graphs, um, how to sketch a graph of a plane um, by locating the three intercepts on the x-axis, y-axis, and z-axis. Yeah, and then we look at sketch of equation x squared plus y squared minus 2, which is a paraboloid. Yeah. So one in this example, we have looked at the intersection of the surface, the xy plane, or sometimes called xy trace. Okay, sometimes also called the xy trace, and this is also called the xz trace. And when we set x equal to 0, um, the yz plane is a parabola. So this is the yz trace. So then with this information, we try to construct a surface. Another helpful information is to sketch what is called the level curves. Yeah. This information on level curves also sometimes give useful information to sketch the graph of a surface. So what are level curves? A systematic way of visualizing a surface z equal to fxy is drawing its contour map. We slice the surface by plane z equal to c. Okay, z equal to c is a plane horizontal to the xy plane. So we slice the surface by planes z equal to c at various levels or at various values of c. Each plane z equal to c intersects the surface in a curve. The projection of this curve onto the xy plane is the level curve or contour lines. So this is one illustration. So we have a surface here in and then we have here two horizontal planes. Say z equal to constant c1. So imagine we have a horizontal plane that slices the surface, and the curve of the intersection is shown here in green color here. Okay, and we have another horizontal plane z equal to say zc2, some constant c2, and this horizontal plane also um, the intersection is this green colored curve here. Yeah? And here the xy plane, right? The xy plane also slices the surface. The xy plane is a level curve z equal to 0. So so imagine the xy plane slice this surface and give us this curve of intersection here in green here. So these are all level curves. Yeah? So now if you draw these level curves on a xy plane, you will get a picture something like this. It's called the contour map of a function. Yeah? So kadang-kadang dalam apa geografi kan, you pernah belajar kan geografi ke, imagine kita ada uh, so kita boleh buat satu model gunung tu dengan membina apa dipanggil contour plot ni seperti ini. Ya. So ada hmm, ada contours yang rapat, ada contours yang agak jarak kan. So contours yang rapat menunjukkan kawasan yang bercuram lah. So misalnya di sini sifar ni, this is the level curve at z equal to 0, the ground level. Menunjukkan ketinggian pada 10, ya. Ketinggian pada 10 unit lah kat sini. Semua titik-titik di sini adalah pada ketinggian 10 unit. Sini ada 20 kan. So maknanya curve ini mengandungi titik-titik pada ketinggian 20 unit. So 30, 40 pun memberi gambaran yang sama. So ini dipanggil contour map, ya, contour map. Where level curves are close together, the surface is steep, ya. Tempat di mana level curves itu adalah rapat, menunjukkan kawasan di situ adalah curam, ya. Where level curves are far apart, the surface is relatively flat. So maknanya tempat yang mana kita dapati jaraknya satu level curve dengan satu level curve yang lain, kalau sini, ya. So di sini dapat memberi kita gambaran mengenai permukaan, ya, sesuatu permukaan. So ada kala maklumat ni boleh juga membantu untuk kita melakarkan satu permukaan. Ini satu contoh tadilah, ini saya dapat daripada satu buku kalkulus. Satu buku kalkulus, ya. Kita ada satu tempat yang gunung ni, pada gunung. So ini ialah dia yang bawah ni adalah dia punya contour, ya. Contour lines, ya. So ada setiap kontur tu ada dia punya ketinggian dia, ketinggian. Sini titik-titik di atas kontur ni pada ketinggian 200 unit ke 200 meter. Sini unit dia 200 meter. So dan seterusnya lah, ya. So kita tahulah kawasan sini agak curam kan. Sebab di sini kontur curve dia rapat, dia agak curam berbanding di sebelah sana dia agak landai kan. So mari kita tengok contoh tu. Buka OneNote. Mana nota semalam Okay, this one yang kita bincang nota semalam ini lah dia yang kita bincang. Okay, sebelum kita tentukan, let's determine the level curves of this same example. Let's consider the same example. Yeah.
Yeah.
Yes.
Speak English, please.
Yes.
Yeah. I don't understand. Can you speak in English, please?
Oh, you are from Egypt. Oh, sorry, I didn't realize we have an international student here.
Oh, okay. Thank you, sir.
Your name is Anas.
Ahmad Atiyah.
Is your name here? Anas Muhammad Atia. Oh, yeah. You are here.
Thank you.
How many international students in this class beside Anas? Anybody else?
Yes, sir.
Hi, Doctor. I'm international. My name is Marco Bono.
Marco Bono. Where are you from, Marco Bono?
From Switzerland.
Switzerland. All right.
Yeah.
Anybody else?
Yes, here also I'm an international student.
Who are? What's your name? Abdurrahman
Yes,
Akram. Oh, okay. Where are you from?
also from Egypt.
Egypt. Anybody else? What about
Yes, sir.
Safran Bakur?
I am also
You
from
are
international.
Matt Emun Hussein.
My name is Mu'min Hussein. Mu'min.
Mu'min. Mu'min. Mu'min.
Yeah,
Oh,
بقول لك
yeah, yeah.
والله.
Mu'min Mahgub.
Yeah,
Right? Oh, you from Egypt also?
no, I'm from Sudan.
Sudan.
Yes.
All right. What about this? MD Eman,
Yes, sir. I'm from Bangladesh.
Bangladesh. What this MD means? What? Muhammad?
Muhammad, yes, sir.
Muhammad Eman. Okay. Also see this one name, Safwan Bakur Harun Abdullah. Yes. You from? Hmm. Anybody else? Just another name, yeah. Aminu Ibrahim Abdul Hafiz, Fahim Tajwar, yeah. Uh, Ibnu Fayyad, you're all foreign students, huh? Okay, all right. Let's discuss. Suppose what are the level curves? Z equal to k. Yeah, Z equal to k. If Z equal to k means what? Suppose I let Z equal to k is a constant. Huh? Suppose k is some constant. If I let Z equal to k in this equation here, x squared plus y squared z, if I let z equal to k in this equation, then we have k equal to, x squared plus y squared minus 2, right? Yeah. What is that equation again? Yeah, this one. So suppose k is a constant. So then this equation can be rewritten as x squared plus y squared equal to k plus 2, isn't it? K plus 2. Now, for a constant k, this is a equation of a circle, right? So this is a equation of a circle, right? Yeah, centered at 0 of radius square root k plus 2. This is the radius k plus 2, right? Circles centered at 0 of radius square root of k plus 2. Yeah. So that means k must be, therefore, k, in order for this radius to be meaningful, that means k plus 2 must be greater than or equal to 0. That means k greater than or equal to minus 2. Yeah. So if k equal to minus 2, we get the level curve. If k equal to minus 2, the level curve is x squared plus y squared equal to 0, isn't it? And here the level curve is just a point. Okay, it's just the level curve is just the point 0, 0, 0, 0. You see from the graph, here is minus 2, right? This is the point minus 2 actually. Yeah. These are the tip of the paraboloid here. So when x is 0, y 0, z equal to minus 2 here. So if k equal to minus 2, the level curve is just this point here, 0, 0, minus 2. If I choose k equal to 2, k equal to 2 implies x squared plus y squared equal to square 4, equal to 4. So this is a circle. Okay, a circle of radius 2. This is x, y. So we want to sketch this contour, isn't it? Contour. So when x is k equal to minus 2 is just a point here. Refers to the level curve k equal to minus 2. When k equal to 2, we have a circle of radius 2. A circle of radius 2. So suppose this is 1, 2, 1, 2. Okay, then we sketch. Let's sketch a circle of radius 2. Something like this. So I'm making a sketch here. So this refers to the green curve, right? Yeah. If I choose k equal to 7, I will get x squared plus y squared equal to 9, isn't it? 9, yeah. So it is a circle of radius 3, of radius 3. So we draw another circle centered at 0 of radius 3 here. And 7. So these are some of the level curves, yeah. So as you can see from the diagram, plane, z equal to constant. Then the curve of intersections are circles. Okay, they are circles here. So sometimes this is also your useful information to sketch a graph of a surface here. Okay, let's see some more example. sketch the graph of z equal to x squared plus y squared minus 6y plus 13, for example, here. Okay. Hmm. It is quadratic in x, in y. In this equation is quadratic in both x and y, right? X and y. So sometimes it is helpful to complete the square. We have this one x squared plus y squared minus 6y plus 13. Yeah. If we complete the quadratic term in y, we have y squared minus 6y. What do we add and subtract here? 9, isn't it? We add 9 and then minus 9, right? Minus 9 plus 13. So we get x squared plus y, the bracket 1, 3 squared, and then 13 minus 9 is a 4. Okay? Hmm. It is almost, this form it's almost the same as the previous example here. It has almost the same form. It's almost the same form. Yeah. So this is also an equation of a paraboloid. This is also an equation of a paraboloid. Is it possible to find the let's try the xy trace. Yeah, let's look at the xy trace. Meaning we set z equal to 0. We want to see how the surface intersect the xy plane. 0, we will get x squared plus y minus 3 squared plus 4 equal to 0. Then we get x squared plus y minus 3 squared equal to minus 4. This is not possible, isn't it? It is not possible. Why? Because x squared is greater than 0. It's always greater than or equal to 0. Y minus 3 squared is also greater than or equal to 0. So here the surface does not intersect the xy plane. Here we can conclude here that the surface does not intersect the xy plane. The surface does not intersect the xy plane. Yeah, yeah sometimes also we have like parabola, right? Intersect the x-axis. Okay, let's look at the the y-z trace, the exact trace. by setting y equal to 0. Okay. How the surface intersect the exact plane. So we have z on the left hand side. Then we have plus 0 minus 3 squared plus 4, which is x squared plus 13, right? Plus 13. So this is a parabola. Yeah. So the surface intersect the exact plane in a parabolic way. Yeah. So the curve of intersection of the surface with the x is a parabola. Okay. What about the yz trace? We set x equal to 0 here. So we get z equal to y minus 3 squared. Y minus 3 squared plus 4. Okay. Z, so we have y minus 3 squared. So this is also a parabola. Yeah. So the surface intersect the yz plane in terms of this parabolic curve here. Okay, what about the level curves? When we look at the level curves, z equal to k. Then we have plus 4 equal to k, right? And this can be written as x squared plus y minus 3 squared equal to k minus 4. Yeah. So this is an equation of a circle. Okay, centered at 0, 3. And here certainly we must choose k greater than or equal to 4. Because k minus 4 must be greater than or equal to 0. Because x squared is always positive. So that means k can only take values greater than or equal to 4. Okay? These are circles. So the level curves are circles centered at 0, 3. Okay, with radius square root of k minus 4. So I think we have enough information now to sketch the curve. The surface. I mean the surface, yeah. We know the surface does not intersect the xy plane. Yeah. Z equal to the graph intersect. So there are circles centered at 0, 3. Suppose this is the point 3. Okay. On the y-axis, let us sketch this one here. Minus 3 squared plus 4. It's a parabola. So on the zy plane, when y equal to 3, z equal to 4. When y equal to 3, z equal to 4. So we have something like this on the zy plane. Okay. I'm sketching a curve here on the YZ plane. This is equal to 4. When x equal to 3, z equal to 4. Yeah. Okay. And the level curves are all circles, isn't it? If we slice, if we slice, say, the surface, was A, they're all circles, isn't it? They're all circles. Yeah. So give you a circle, something like this. So this shows that the surface is a paraboloid. It's also a paraboloid. Something like this, yeah. So that is the sketch. Any question for this example here?
Excuse me, doctor.
Yes.
When a question asks to sketch the level curve or the how many intersections should we make if they don't say how many intersections to do?
In some questions they specify you the value of k, isn't it? In some questions the values of k are sometimes given. Let's look at one example here. Test. Yeah, this is a sample test 1 question from previous semester. Okay, here. Sketch the level curve for z equal to -4 and 0 only. Okay, for z equal to -4 and 0 only. The values of k are given specifically here. All right. We discussed this problem yesterday, right? We solved part 1 and part 2. So let's try. Let's try this. Part 3 now. Sketch the level curve. Let me copy this. I cannot scroll this. Cannot scroll this downward. Why? Got stuck. It freeze. Nothing happens. Not responding. What shall I do? It is not responding. What should I do? Maybe I need to close it. Close it and then open it again. Let's try.
Maybe you have to restart the app.
Okay. Okay, now it's working. Let's look at another example. It's the sample test question. Yeah. We have already determined the alternative form using completing the square, right? Using completing the square. Yes, we have rewritten this equation as z um, equal to x minus 1 squared plus 3 times y plus 1 squared minus 4, isn't it? We have uh, yesterday. Yeah. Okay. In part 3, what is the part 3? Here is the part 3. Sketch the level curves for z equal to minus 4 and 0. Yeah. So let's look at the case where z equal to minus 4. When z equal to minus 4, we get x minus 1 squared plus 3 times y plus 1 squared minus 4 equal to minus 4. So this reduces to x minus 1 squared plus 3 times y plus 1 squared equal to 0, right? Okay, so what is this? What does it mean? What does it mean? Point, right? The level curve is just a point. It means the point xy is minus 1 and minus 1, isn't it? Just a single point. Yeah. Okay, what about the other case? The other level curve is at z equal to 0. It means that the surface z equal to minus 4, that means the surface intersect the horizontal plane z equal to minus 4 at just 1 point only. 1 point only. Yeah. And z equal to 0 means the xy plane, right? This is the xy plane. So when z equal to 0, the equation becomes x minus y squared plus 3 times y plus 1 squared minus 4 equal to 0. X minus 1 squared plus 3 y plus 1 squared equal to 4. Now what is this equation? Does anybody here know what is the graph of this equation?
Is it an ellipse, Doctor?
You need to sketch, right? Sketch the level curve. Yeah. Yes, you're right. This is an ellipse. What is the general form of an ellipse? Um, this x minus h squared over a squared plus y minus k squared over b squared equal to 1, right? This is the general form of an ellipse centered at hk. There's also major segment, minor segment. Yeah. So if I have this centered at somewhere hk, suppose this is the point hk, so it is an ellipse. Huh? This something that looks like this. Yeah, something that looks like this. Not good. Let me. It has okay, something that looks like this. Yeah. Hmm. So the distance here from here to here is A. The distance from here to here is B. Okay. Yeah. So let's rewrite this last equation in the standard form. Standard form means the left hand side is 1. So we divide both sides by 4. Then we get x1 minus 1 x 3 times y plus 1 squared over 4 equal to 1. Now, again, we want to write this in the standard form as written in green there. So this is x minus 1 squared over 2 squared, y plus 1 squared over 2 over square root 3 squared equal to 1, right? So now we have rewritten this equation in the standard form. A equal to 2 and B equal to 2 square root 3. And the center is at 1 minus 1. The center point is 1 minus 1. Where is the center point? Let me plot the point 1 minus 1. So here is the point 1 minus 1. When z equal to minus 4, it's just it is just a point, right? It is just this point here. Just this point when at the level curve z equal to minus 4, it's just this point there, 1 minus 1. When z equal to 0, it is an ellipse. Yeah, it is an ellipse. With a equal to 2, a equal to 2. This is 1. So let's measure 2 units. 0 or 1. Minus 1. So measure 2 units, right? Okay. So yeah, it is from this point to this point. The ellipse is from this point to this point. And then what about B? B is 2 over square root 3. Okay. So here we have A equal to 2. B is 2 over square root 3, which is less than 1, right? What is the value? What is 2 over square root 3? If you use your calculator, it's 1.15. Only 1.15, right? So it is slightly above the x-axis. It is slightly above the x-axis. From here to here, something like this. So now we have this enough information to sketch the level curves. So something that looks like this. Okay, just a sketch. It's just a sketch, so doesn't has to be so exact. But make sure your sketch is looks like an ellipse, not looks like a circle. Yeah. So this ellipse is the level curves at z equal to what? 0, huh? Yeah. It is a 0. In fact, it is a ellipsoid, isn't it? The graph is an ellipsoid. Yeah. The complete graph is an ellipsoid. The, mm, when z equal to minus 4, it is at this just 1 point here. Okay. What is that point? 1 minus 1 minus 4. 1 minus 1, and then 4 units down here. So this is the point. 1, 1 minus 1. 1 minus 4. So somewhere here. Okay. We have 1 here, minus 1, and then 4 unit down here. Something like that. Mm. Mm. Suppose minus 4 is over. Okay. So it is an ellipsoid. This is the point 1 minus 1 minus 4. Okay. And when z equal to 0, 1 minus 1, it is an ellipse, right? It is an ellipse. It is an ellipse. This is on the xy plane. This is x. This is y. So where is that ellipse? On the xy plane. Centered here. This is the point 1 minus 1. X. It is something like along the, it is elongated here, right? Somewhere here. Thing that looks like this. Yeah. Or maybe no. Yeah, something like that. On the XY plane. Mhm. So it is something that looks like this, the ellipsoid. Yeah, ellipsoid. Yeah. Hmm. Any question for this example? You want to have a 10 minutes break? Yesterday, some of you suggested that.
Can do it, can.
Okay, so let's have a 10 minutes break. So that means we continue around what, 12, 3, yeah?
Okay, doctor.
Here.
Okay.
Okay, doctor.
Okay, welcome back everyone. Let's continue with our lecture. Okay, let me first share my computer screen. The screen that I'm sharing.
Yes, doctor.
Okay, here is the computer plot for the function that we have just discussed. Yeah. Remember just now I discussed this example, right? This example for this function x squared minus 2x plus 3y squared plus 6y. And we did a sketch, isn't it? We did a sketch of this of the level curve z equal to 0, z equal to 4, and then with that information we make a sketch. So this is like an ellipsoid. And here is the computer plot. Here I'm using the software Mathematica to generate this 3D plot. So the equation that we discussed just now is was, x squared minus 2x plus 3y squared plus 6y. So here I have specified the range of values for x and y, and then this another command here. I have specified the level curves are k less than or equal to 10. Remember this is z, right? Z equal to k. I have limit k less than or equal to 10, and to make sure that we have the same unit for the x-axis, y-axis, and z-axis. They are all using the same scale. Yeah. So you can see here. This is the image. The image. I can enlarge this also by dragging this down. Yeah. So you can see from above that it is an ellipse. It is an ellipse. Yeah. It is an ellipse. So the level curves, they are all ellipses. And you can see that even there's a minimum point there. There's a minimum point here. Okay. So nowadays we have many mathematical software that can generate these surfaces, very quickly. Yeah. Have you heard of the software Mathematica?
Yes.
Yes.
Yes, but never use.
Uh,
No.
so yeah, our UTM used to subscribe, Mathematica, subscribing. But Mathematica has MATLAB, yeah. I mean, the UTM has MATLAB. So I don't know how to generate this using MATLAB. If maybe you are, if you are familiar with MATLAB, maybe you can generate this surface using MATLAB. Yeah. So this is another example of a surface. Sometimes it's not easy, to sketch a 3D for some complicated graphs, maybe for equation. Maybe we have to use a computer. For example, here this is z equal to e to the power of 2x minus y squared plus xy. Yeah, it's not easy. And here I have applied Mathematica to generate this graph shown below here. We have it is defined for all x and y, but here I have restricted the domain here as shown. Okay, so this is so we built the one thing nice about this Mathematica is that you can also rotate the graph at 360 degrees. You can also rotate it, see how it looks from each side. Yeah. Mm. I will upload this example also in the e-learning. Yeah. Yeah. This is another example. Log of for log x plus y to be meaningful, x plus y must be greater than 0. That means y must be greater than minus x. Y equal to minus x is aligned. So this is the line actually, y equal to minus x. Yeah, the graph is, the function is undefined uh, below the line y equal to minus x. Yeah, so that's why you don't see any graph on this part here, because the domain is minus x. Yes. This is the absolute value of x plus y. The absolute value of x plus y. Z equal to the absolute value of x plus y. Yeah. Another, let's do another example. Okay. Suppose we want to sketch the graph z equal to the square root of x squared plus y squared. So this is also a function of two variables. It is defined for all xy, right? Yeah. Uh, um, what is the range? What is the domain? The, if I call this fxy, and the domain of f is uh, all real numbers, isn't it? Because x squared is always positive, greater than equal to 0. Y squared is also greater than equal to 0. So, um, so it is defined for all xy. Yeah, it is defined for all real numbers x and y. Um, so don't write. Sometimes there's a tendency, to write in this form. X squared plus y squared greater than or equal to 0, because the square root is defined only for non-negative real numbers, right? So sometimes student might be tempted, to write in this second form, but actually uh, don't write it in this form. You should write it in the first form. That xy means the entire xy plane. Okay, the domain is actually the entire xy plane. Yeah. What about the range for this function? Anybody? What do you think is the range for this function?
All real numbers.
Equals to 0.
Must be greater than equal to 0, right? Square root cannot take negative numbers. Yeah. Because from your experience, y equal to square root x is always greater than equal to 0, right? So similarly here, z is any real number such that z is greater than or equal to 0. Yeah, that is the range. Okay, what about the graph? Let's sketch a graph. Let's look at the three traces, the xy y trace, meaning z equal to 0. Then we have square root of x squared plus y squared equal to 0. So that means just a single point, right? The trace is just a single point. So that means the surface intersects the xy plane at just a single point at the origin, at 0, 0. Yeah. What about exact trace? The exact trace is obtained by setting y equal to 0. Then we have z equal to square root of just x squared, isn't it? Just x squared. And the absolute value of x squared is the same as the modulus of x. It's not x, but the modulus of x. Okay? It's not x. Square root of x squared, to be precise, is equal to the absolute value of x. Yeah. So recall in calculus, if I have y equal to absolute is what? It's in this form, isn't it? It's a V shape. V shape. Yeah, let me try again. We have the line here y equal to x and another line here y equal to minus x. Okay, this is the line y equal to x and this is the line y equal to minus x, right? So this is the graph, the line here. So similarly, z equal to modulus x is the surface intersect the in terms of this z equal to x. Let's start sketching whatever information that we have. X, Y, Z. So the XY trace is just a single point, 0, 0. It's just a single point here. That means the surface intersect the XY plane at the points at the origin there. Yeah, X0, Y0, Z0. And the exact trace. So when y is 0, the surface intersect the exact plane um, mm, the curve of intersection is z equal to absolute value of x. So this is the shape of the curve z equal to modulus x. Okay, the one in blue here is the is the is the equation z equal to modulus x there. Okay, so what we have another trace which is the yz trace. By set z equal to square root of y squared, which is absolute value of y. Okay, so the curve of intersection of the surface on the yz trace. Oh, it's exact trace. Oh, I'm sorry. The exact trace. Oh, I see. Made a mistake here. Uh, it is on the exact plane, right? Z equal to absolute value of x is on the exact plane, on the exact plane. So I should draw maybe something like this. Then another curve is behind the ZY plane. So something like this. Yeah. And then we have Z on the YZ plane. We have this equation here also. Yeah. We do it in green color here. Something like this. Okay. So this is Z equal to modulus Y. The one in blue refers to Z equal to modulus X. Okay. Let's look at the level curves now. The level curves. By setting, say, Z equal to K. Then we have square root of x squared plus y squared equal to k. Now, if we square both sides, we get x squared plus y squared equal to k squared. Now, these are equations of circles, isn't it? Circles centered at 0 of radius k. So that means the horizontal plane z equal to k intersect the surface in circles. Okay, intersect the surface in circles. Yeah. So suppose we have this circle here, right? The plane, the intersect here is say k, z equal to k. The level z equal to k, any k greater than equal to 0, for any plane z equal to k, for any horizontal plane z equal to k, greater than 0, intersect the surface in circles. So what do you think the surface is actually? What is the surface? It's a cone. Yeah, it is the cone. It is a cone. Uh, it is a cone. So we have a cone here. All right. It is a cone. It's an inverted cone actually. It is an inverted cone. Any question for this example?
No, doctor, thank you.
Okay, let's try plot this. Make this 3D plot using Mathematica. Let's see what do we get. Copy. It is the square root, right? The equation is square root. SQRT x squared plus y squared Yeah. Okay. Let's limit the domain x between -7 and 7 region function where we want the square root to be say less than or equal to k, right? Control k here to be less than or equal to 10. Shift enter. Yeah, so this is the what it looks like. It is a cone. It is a cone. Okay. Any question? This is a circular cone. This is a circular cone. This is a circular cone over this rectangular domain here. It's minus 7, 7, y between minus 7 and 7. Okay, let's look at another example. Suppose you want to sketch the graph of z equal to 4 minus y squared. Yeah. But this equation only contains the variable y. But you must still regard this as a function of two variable. But it is independent of x. It is independent of x. Yeah. Think of this as a function of two variable of x. Yeah. So on the xy, on the zy plane, the equation is parabolic, right? This is a parabolic equation. So let's look at the trace. What is the xy trace? By setting z equal to 0, we get 0 equal to 4 minus y squared, which means y squared equal to 4, which means y equal to plus or minus 2. Yeah. So y equal to plus or minus 2, independent of x. It is a line, isn't it? Y equal to plus minus 2 is some line. We have x here, y, and z. Z equal to 0 means on the xy plane. So the surface in along the lines y equal to plus or minus 2. So here is the line, say y equal to 2, and here is the line y equal to minus 2, right? Yeah. And it is independent of x, so that means it is a horizontal line, x-axis. Yes, parallel to the x-axis. What about the trace? Is it possible? Exact trace. Exact trace means what?
Y is equal to 0.
Exact trace means y equal to 0. 4 only, right? Z equal to 4. Yeah. So on the xy, on the exact plane, z equal to 4. Z equal to 4 somewhere here. On the exact plane, is it exact plane? Yeah. The graph intersects 4 on the exact plane. The surface intersect along the line z equal to 4. Z equal to 4, something like this, yeah. Z equal to 4. On the exact plane, the surface intersect the exact plane along the line z equal to 4. Straight line z equal to 4, yeah. Independent of x. Then finally, we have the yz trace. Yz trace, which means x equal to 0, right? X equal to 0. There's no x to substitute equal to 0, so it is just simply z equal to 4 minus y squared. So along the yz, okay, the surface intersect the yz plane and this parabolic curve, z equal to 4 minus y squared. So what is the shape? What is the shape? Is it when y is 0, z equal to 4. When z is 0, it's a parabola. Yeah. So it is this shape here. It extends downward. So what is the what is the shape of the surface?
Like a tunnel.
Control.
Ah,
Tunnel.
it's like a tunnel. Looks like a tunnel. Yeah. So the surface is thing like this. Yeah. Isn't it? Yeah. It's something like this. Yeah. Okay. Yeah, the surface, but it extends infinitely downwards. Yeah. So this is the another example. Yeah. Okay, so there are other what is called common surfaces. Yeah. Yeah, this is the ellipsoid. This equation here describes an ellipsoid. When all A, B, C are equal, we will get a sphere, right? Yeah, we will get a sphere. Then we have the elliptic paraboloid here, form of equation of an elliptic paraboloid. The trace in the xy plane is a point. When z is 0, so x0, y0 is a point, yeah, the origin. The traces a parabola. The xy trace. Xy trace means what? Z equal to ellipses. Traces in planes parallel to and above the xy plane, or when z equal to k. Okay, when z equal to k, the level curves are ellipses. Yeah. If I set z equal to k, then the level curves are ellipses. Yeah. Ellipses. Yeah. Parabolas. Yeah. If I set y equal to 0, then we have a parabola. If I set x equal to 0, again we have a parabola. So it is an elliptic paraboloid. We also have the hyperbolic paraboloid. Looks like a saddle here, horse saddle. Yeah. The elliptic cone. Yeah. Circular cone. Circular cone consists of two parts. Yeah. The upper part and the lower part. Yeah. This is called hyperboloid of one sheet, hyperboloid of two sheets. Yeah. So these are some of the common surfaces you need to be familiar with. Sometimes when we discuss the double integral, sometimes again we need to recall some of the stuffs related to surfaces. Yeah. I will upload this also in the e-learning. Let's see. What have we discussed already? I did not follow the weekly plan here. For example, according to this plan, after we have discussed domain and range, I should discuss partial derivatives. I went straight to this graphing of functions of several variables. I think it is better for me to do it this way. Yeah. So I will discuss partial derivatives next week. Yeah. Next week, I will discuss them. So I want to let me finish this topic on graphing of functions of several variables. Yeah. And next week I will talk about the. Okay. But sometimes you also let's look at this one question here. Where's that? That's okay. Look at this question number 2 here. This is a function of 3 variables, right? Previously, we have discussed function of 2 variables, the graphing, the domain, range, and also the graphing, the graph of a dimensional space. In this question number 2, it is a function of 3 variables. And here you are required to sketch the level surface of the function w equal to 0 only. Is it possible to sketch this function of 3 variables? In what dimension? The surface. You see, if you have a function of 3 variables, then the surface is 4-dimensional, isn't it? It's 4-dimensional. It is impossible because we are trapped in this 3-dimensional world. It's not possible for us to sketch to graph a four-dimensional surface. Yeah. But here the question asks only the level surface, mean for W equal to 0.
Excuse me, doctor.
Yes.
Should we in this see to the other side of the equal sign? Only then to sketch it.
I'm sorry. I don't understand. What
Should,
is it?
should we rewrite the equation as z equals to square root 1 minus x
Which
squared?
equation? This for this example or the previous example?
For the example you're doing now, the new example.
This one.
Yeah, the
This one?
three. Yeah, the three
Uh-huh.
variables.
The question asks for sketch the level surface of the function. Okay, let's talk about domain. Huh? What about the domain? Let's talk about domain first. What is domain? The square root is defined only for non-negative real numbers, right? It's only defined for the non-negative real numbers. So that means we must have 1 minus. There is no restriction on z, but for the square root sign, we have some restrictions. That we must have for 1 minus x squared minus y minus 0. For the function f to be well defined, we must have this condition. The expression under the square root sign should be greater than or equal to 0. Yeah, equal to 0. So that means y should be less than or equal to x, what is it, x squared minus 1, right? Y less than or equal to 1 minus x squared. So z can be any real number. Yeah? So we can write the domain of f consisting of all points x, y, z such that y is less than 1 minus x squared and z can be any real number. Z can be any real number. Yeah. Of w. What about the range of f? Yes. We know that the square root of 1 minus x squared minus y is always greater than or equal to 0, right? For x, y in the domain. Take any real numbers, right? So what can you say about here, w? Can take any real number, isn't it? W here can take any real number because z can take any real number. Yeah. Even though square root of 1 minus x squared minus y is greater than or equal to 0, but z can take, you can also take any real numbers. So the range of f is the entire real line there. Okay, what about the level surface now? The level surface. I think I'll continue this next week. Talking about level surface, I will discuss few examples related to level surface. Yeah, for function of three variables. And next week, after that, I will start talking about the what? The partial derivatives. Yeah. Okay, I think enough for today. So let me show you the the QR code for attendance. I uploaded the tutorial one, for in the e-learning. So take a look.